Hi everyone, this video is on the challenge question of mixed exercise 11 and it's part B. So we want to integrate f of modulus x, where f of x is x squared minus x minus 2. So first of all, we should start by just factorizing and finding the roots of this quadratic so that we can draw the graph of that. So we'll have x minus 2 times x plus 1 is equal to 0, where x is equal to 2 or x is equal to minus 1. So a quick sketch, actually, I did that in the previous video. So is this, because the roots are minus 1 and positive 2, and then we draw this from minus 3 to positive 3. Now, the interesting part here is that we want to integrate f of modulus x. So let's rewrite this quadratic and we write this as modulus x squared for the first term, and then minus modulus x and minus 2. Now here we should be careful because this part, which is modulus x and then a squared, is basically the same as having just x squared, right? Because the modulus doesn't do anything here, because x squared is always positive anyway, right? So we can just write this as x squared. So these two are equal. However, the second term has to be minus mod x minus 2 is equal to. So the powerful thing to remember is about even functions, because that's the key to solving this question. Because a function is called even if g of x is equal to g of minus x. And now when you look at this function, and if you just apply this fact, then it's essentially going to be an even function. Because in this case, if we, let's say, substitute minus x into here, then we'll get x squared minus x minus 2, which is the same as if we just substitute x. We'll also get x squared minus x minus 2. So if you substitute x into f of x, we'll get this. And also if you substitute minus x into here, then we'll also get x squared minus x minus 2. So therefore, this is an even function. Now, the reason that we needed to know that is because there is a very powerful technique in terms of integrating even functions, is that when we have a bound that is symmetric, because even functions are symmetric. So in this case, when we are integrating this from minus 3 to 3, we can actually just write this as from 0 to positive 3 and then drop the modulus, because here the value of x is going to be positive, right? So we don't need modulus for that. And this allows us to integrate this as usual. So we just now integrate this as, so x squared integrates to 1 over 3x cubed minus x squared over 2 and then minus 2x. Now we just substitute 3 and 0. And actually, I just forgot to mention that we always double that value. So when we have an even function, and since even functions are symmetric, so we can just rewrite this as 2 times integral of 3 over from 0 to 3. And the reason is because if you just, if I show you a quick sketch, I think that's going to be helpful. So if you draw this graph, it's going to roughly look like this. And it's not the best graph here, but the idea is that this side is symmetrical to this side. So instead of integrating from the minus 3 to 3, which is the whole region, since it's symmetric, we can only integrate from 0 to 3 and then double that value. So that's what exactly we are doing. And so I forgot to write this 2 times at the beginning. Yeah, so now we just evaluate, and then the final answer, once we have substituted 3 and then take away 0 substituted, is going to be simply equal to minus 3.